Hello everybody, I'm just going to talk a little bit deeper about the SQC or statistical quality control and how it is created. This is similar to a chart we looked at for the red bead experiment in class, in which Deming uses to determine whether something is common cause or special cause. But let's take a little deeper on how just the lines are created in terms of the mean, standard deviations, upper limits, lower control limits. So I'm going to demonstrate here how those things are calculated. And maybe this is a quick review of just your back way, back to when you were in statistics, and maybe some of you know this, but I'm going to be quick to kind of just show how standard deviation is calculated, and that kind of gives a refresher on how our SQC is created. So as you know, the mean or mean U is what it's referred to as, or X bar. People are pretty familiar with what an average is. That's when you add up all the data points and how many there are. And so in this particular just example, I have 5 points. I add up the points here. It equals 25, divide by how many points there are, and 5. Basic average, right? Okay, so, but also what the SQC has is what's called standard deviation, right? To determine the upper and lower control limits, we use what's called standard deviation, which is by sigma here, all right? So here's a complicated formula that we use to calculate standard deviation. It looks rather complicated, but if you really break it down, it makes sense to why it shows variation. Now variation, this is the general way we look at variation, all right? There's also range, which is like the very elementary way of doing it, which is just subtract the highest value minus the lower value. That gives you a very general variation. But statisticians use standard deviation as a way to calculate the overall variation. So let's break this down. So how a standard deviation is calculated is first we calculate the deviation for each point on the graph. So you'll notice here, this x sub I minus mean u right here, that's called the deviation. So that's how far a data point is from the mean. So you can notice that 7 here is 2 points away from the mean. So 7 minus 5 is 2, 1 minus 5 is negative 4. And so that's how we get what's called the deviation. Now, obviously, if we were to add up all the deviations, that it would equal 0, okay? So to get rid of the negative signs, what we do is we square them, which is where this symbol comes from right here. So we square all the deviations to make them positive. We add them all up, which in this case equals 40. Now what this is, this 40 then is calculated into here. So this number right here, this 40, is what this little symbol right here calculates. I divide by how many data points there are, which is 5, and this is 8. We call this value 8, or it's referred to as the variance. So before we square root something, it's called the variance. All right, then finally, after all this data here, we take the square root of the variance, which gives us our standard deviation. Okay, the reason why we square rooted, as you know, when we were doing our calculations here, we squared all the data points to make them positive. And so to make it back to the data in which it reflects the mean in our original data, we have to square root it. So that gives us our standard deviation. Okay, so again, just a quick review. Deviation is the distance every point is away from the mean. We square it and then we average it. So it's essentially like, if you go back to what the mean is, we've essentially taken all the differences it is from the mean and then just found the average of those differences. And that gives us the standard deviation. And so with that data in mind, now in statistics it's called an outlier. Now what Deming calls an upper control limit and a lower control limit, same thing. How we calculate outliers or control limits is taking the mean plus or minus 3 times the standard deviation. So in this case, if we were to sort of start to construct a SQC for this just simple data here, we would say that the upper control limit would be 13.4, okay? Now we don't have to go below this because time can never be negative, so really the negative 3.4 is probably not realistic in this sense, all right? So all put together here, if we were to look at a situation as an example here, here would be a chart that kind of shows data put in a SQC. And so you can see this random chart here shows the data points going back and forth. You can see the upper control limit here, lower control limit. The average is right here. And then you'll notice that this one fell, as we've talked about in this presentation so far, that something that falls out of those control limits could be classified as a special cause. And so there's a brief kind of rundown of just overall general statistics. Now we're going to do a little experiment where you get to try out and see how a how you can use and explain possible common cause and special cause. Have a great day.